Winter season. Winter, coldest season of the year, between autumn and spring. The name comes from an old Germanic word that means time of water and refers to the rain and snow of winter in middle and high latitudes. In the northern hemisphere it is commonly regarded as extending from the winter solstice, year's shortest day, December 21st or 22, to the vernal equinox, day and night equal in length, March 20th or 21, and in the southern hemisphere from June 21st or 22 to September 22nd or 23. The low temperatures associated with winter occur only in middle and high latitudes. In equatorial regions, temperatures are almost uniformly high throughout the year. For physical causes of the seasons, see season. The concept of winter in European languages is associated with the season of dormancy, particularly in relation to crops. Some plants die, leaving their seeds, and others merely cease growth until spring. Many animals also become dormant, especially those that hibernate. Numerous insects die. The tilt of the Earth's axis relative to its orbital plane plays a large role in the formation of weather. The Earth is tilted at an angle of 23.44 degrees to the plane of its orbit, causing different latitudes to directly face the Sun as the Earth moves through its orbit. This variation brings about seasons. When it is winter in the northern hemisphere, the southern hemisphere faces the Sun more directly and thus experiences warmer temperatures than the northern hemisphere. Conversely, winter in the southern hemisphere occurs when the northern hemisphere is tilted more toward the Sun. From the perspective of an observer on the Earth, the winter sun has a lower maximum altitude in the sky than the summer sun. During winter in either hemisphere, the lower altitude of the sun causes the sunlight to hit the Earth at an oblique angle. Thus a lower amount of solar radiation strikes the Earth per unit of surface area. Furthermore, the light must travel a longer distance through the atmosphere, allowing the atmosphere to dissipate more heat. Compared with these effects, the effect of the changes in the distance of the Earth from the Sun, due to the Earth's elliptical orbit, is negligible. The manifestation of the meteorological winter, freezing temperatures, in the northerly snow-prone latitudes is highly variable depending on elevation, position versus marine winds and the amount of precipitation. For instance, within Canada, a country of cold winters, Winnipeg on the Great Plains, a long way from the ocean, has a January high of minus 11.3 degrees Celsius, 11.7 degrees Fahrenheit, and a low of minus 21.4 degrees Celsius, 6.5 degrees Fahrenheit. In comparison, Vancouver on the west coast with a marine influence from moderating Pacific winds has a January low of 1.4 degrees Celsius, 34.5 degrees Fahrenheit, with days well above freezing at 6.9 degrees Celsius, 44.4 degrees Fahrenheit. 3. Both places are at 49 degrees in latitude, and in the same western half of the continent. A similar but less extreme effect is found in Europe. In spite of their northerly latitude, the British Isles have not a single non-mountain weather station with a below-freezing mean January temperature. Meteorological reckoning is the method of measuring the winter season used by meteorologists based on sensible weather patterns for record-keeping purposes, so the start of meteorological winter varies with latitude. Winter is often defined by meteorologists to be the 3 calendar months with the lowest average temperatures. This corresponds to the months of December, January and February in the northern hemisphere, and June, July and August in the southern hemisphere. The coldest average temperatures of the season are typically experienced in January or February in the northern hemisphere and in June, July or August in the southern hemisphere. Nighttime predominates in the winter season, and in some regions winter has the highest rate of precipitation as well as prolonged dampness because of permanent snow cover or high precipitation rates coupled with low temperatures, precluding evaporation. Blizzards often develop and cause many transportation delays. Diamond dust, also known as ice needles or ice crystals, forms at temperatures approaching minus 40 degrees Celsius, 40 degrees Fahrenheit, due to air with slightly higher moisture from above mixing with colder, surface-based air. They are made of simple hexagonal ice crystals. The Swedish Meteorological Institute, SMHI, defines thermal winter as when the daily mean temperatures are below 0 degrees Celsius, 32 degrees Fahrenheit, for 5 consecutive days. According to the SMHI, winter in Scandinavia is more pronounced when Atlantic low-pressure systems take more southerly and northerly routes, leaving the path open for high-pressure systems to come in and cold temperatures to occur. As a result, the coldest January on record in Stockholm, in 1987, was also the sunniest. Accumulations of snow and ice are commonly associated with winter in the northern hemisphere, due to the large land masses there. In the southern hemisphere, the more maritime climate and the relative lack of land south of 40 degrees S makes the winters milder. Thus, snow and ice are less common in inhabited regions of the southern hemisphere. In this region, snow occurs every year in elevated regions such as the Andes, the Great Dividing Range in Australia, and the mountains of New Zealand, and also occurs in the southerly Patagonia region of South Argentina. Snow occurs year-round in Antarctica. Volcanic winter, cooling at Earth's surface resulting from the deposition of massive amounts of volcanic ash and sulfur aerosols in the stratosphere. Sulfur aerosols reflect incoming solar radiation and absorb terrestrial radiation. Together these processes cool the troposphere below. If sulfur aerosol loading is significant enough, it can result in climate changes on a global scale for years after the event, causing crop failures, cooler temperatures, and atypical weather conditions across the planet. Explosive volcanic eruptions are capable of sending pulverized rock, sulfur dioxide, and hydrogen sulfide, H2S, into the stratosphere. Although volcanic ash can decrease regional visibility for a few months after the eruption, sulfur compounds injected into the stratosphere form sulfur aerosols that can reflect a portion of incoming sunlight for several years. As the concentration of sulfur aerosols increases in this region of the atmosphere, greater reflection occurs. Surface heating declines as a result, and thus cooler temperatures predominate at Earth's surface. Compared with the underlying troposphere, the stratosphere is relatively devoid of atmospheric turbulence, and thus these aerosols may remain in the stratosphere for several years before settling out. There is evidence that volcanic winters have occurred several times throughout Earth's history, with varying degrees of severity. One of the more severe episodes of volcanic winter occurred sometime between 71,000 and 74,000 years ago when Mount Toba, a volcano on the island of Sumatra, expelled possibly as much as 2,800 cubic kilometers, about 670 cubic miles, of ash into the stratosphere. Ice core evidence suggests that average air temperatures worldwide plunged by 3-5 degrees Celsius, 5.4-9.0 degrees Fahrenheit, for years after the eruption. Some model simulations estimate that this temperature decline may have been as much as 10 degrees Celsius, 18 degrees Fahrenheit, in the northern hemisphere in the first year after the eruption. Some scientists maintain that this event sent the planet into a severe ice age that nearly caused the extinction of modern humans. A study of a contemporaneous human settlement in southern Africa suggests that some areas of Earth with a plentiful food supply may have served as refuges for human beings in the years after the eruption. From June 1783 to February 1784, the Laki fissure in Iceland extruded about 12.5 cubic kilometers, 3 cubic miles, of lava that covered about 565 square kilometers, 220 square miles, considered the greatest lava eruption on Earth in historical times. The enormous quantity of volcanic gas that was released caused a conspicuous haze over most of continental Europe. Some scientists link the presence of this haze over the region to the severity of the winter of 1783-84 in the northern hemisphere. During the 19th century, 2 volcanoes in the Indonesian archipelago were associated with volcanic winters. The first event was caused by the eruption of Mount Tambora, a volcano on the island of Sumbawa. It expelled about 100 cubic kilometers, 24 cubic miles, of ash into the atmosphere in 1815. This event had the effect of reducing the average global temperature by as much as 3 degrees Celsius, 5.4 degrees Fahrenheit, in 1816, causing the year without a summer in parts of North America and Europe. The second event was caused by the eruption of Krakatoa in 1883. This eruption discharged nearly 21 cubic kilometers, 5 cubic miles, of rock fragments, destroying much of the island of Krakatoa, and the surrounding region was plunged into darkness for 2.5 days because of ash in the air. The fine dust drifted several times around the Earth, causing spectacular red and orange sunsets throughout the following year. Some scientists contend that this eruption upset weather patterns for years afterward. In 1928, after a period of renewed volcanic activity, a new island called Anak Krakatau, child of Krakatoa, emerged from the ocean in the spot where the original volcano once existed. Monsoon, a major wind system that seasonally reverses its direction, such as one that blows for approximately 6 months from the northeast and 6 months from the southwest. The most prominent monsoons occur in South Asia, Africa, Australia, and the Pacific coast of Central America. Monsoonal tendencies also are apparent along the Gulf Coast of the United States and in Central Europe. However, true monsoons do not occur in those regions. For further information on prominent monsoon regions, see Indian monsoon, West African monsoon, Malaysian Australian monsoon, and North American monsoon. The primary cause of monsoons lies in different warming trends over land and sea, though other factors may be involved. Seasonal changes in temperature are large over land, but small over ocean waters, and monsoons blow from atmospheric heat sinks, that is, cold regions with high atmospheric pressure, toward heat sources, warm regions characterized by low atmospheric pressure. Consequently, monsoon winds typically travel from sea to land in summer and from land to sea in winter. For example, the heat source involved in the Indian summer monsoon resides over the plateau of Tibet and the eastern foothills of the Himalayas, while the heat sink occurs over the southern Indian Ocean and Madagascar, a region where relatively cloud-free air cools by emitting infrared, or long-wave, radiation into space. Likewise, the heat source for the Australian summer monsoon resides over the area in which many meteorologists call the Maritime Continent, a region made up of parts of Southeast Asia and the islands of Indonesia and the Philippines, while the heat sink resides over Siberia. Most summer monsoons have a dominant westerly component and a strong tendency to ascend and produce copious rainfall, which occurs as a result of the condensation of water vapor in the rapidly rising air. The intensity and duration of these rains, however, are not uniform from year to year. Conversely, the winds of winter monsoons have a prevailing easterly component and a strong tendency to diverge, subside, and cause drought. The poleward limits of monsoon systems are often sites of sharp changes in wind direction. In India, for example, the monsoon blows from the southwest in July and August. In north of India, the winds are from the east. In northern Australia, the monsoon arrives from the northwest during January-February. At the southern limit of the Australian monsoon, the winds turn easterly. Climatic patterns reminiscent of monsoons also occur in areas outside of the prominent monsoon regions. In Central Europe, where the average wind direction in summer differs some 30 degrees to 40 degrees from that of the Atlantic, there are monsoonal tendencies that occur not as a continuous flow, but rather intermittently within frontal depressions, bringing cool, cloudy weather, rain, and thunderstorms. Some see in this climatic pattern a true monsoon, but it is obvious that it is only an embryo monsoon that results in weather singularities. The latitude is too high for a true monsoon to arise. In addition, the Gulf Coast of the United States is prone to climatic patterns with monsoonal tendencies. However, the seasonally consistent winds characteristic of true monsoons do not emerge.